All right, guys, welcome back to Chapter 7 notes. So we're going to expand on some of those ideas that we saw from the first part of the notes. So something that I did not have you guys write down was how to find, or where R is coming from, I guess I should say. So in order to know where R is coming from, we need to understand that there's two kinds of graphs, right? So there's our scatter plot. So a scatter plot, I'm actually going to do like a super small data set example. And I'm just going to make up some data right now. So I'm going to have my independent variable. Let me make sure you can see where I'm drawing. There we go. My independent variable, oh gosh, let's put, we'll do age in years. And my dependent variable will be, how about, we'll do the one with reading level, right? So how many pages you can read in like per minute. So pages read per minute. So we'll start off with, and let's assume that this is like a basic lower level book, okay? So let's say we have a 7-year-old and they can read, say, 1.5 pages per minute. And we have a 5-year-old that can read, say, 0.5 pages per minute. Maybe we have a second 5-year-old and he can read 1 page per minute. We'll have a 6-year-old that's reading maybe 1 page per minute. An 8-year-old that's reading 2.5 pages per minute. And maybe we'll do one more. How about a 10-year-old who's reading 4 pages per minute? Okay, so we're going to talk about the difference between a scatter plot and a standardized scatter plot. So on a scatter plot, if I were to sketch this data, and remember, this is a rough sketch. We're going to go through this a little quickly, so I didn't give you graph paper. We can break the graph. We don't have to start at 0. So I'm going to start at 5, and then 6, 7, 8, 9, and 10. And remember, we think that age is our independent variable, right? We can't control our age, but our reading, we think, is linked to or related to or responding to our ages. So age in years. And then the number of pages read per minute. So again, this time it would be okay to start at 0, so I won't break my axis. So this will be 0, 1/2, 1, 1.5, 2, 2.5. Oh, I'm going to run out of room. So let me shrink my axis a little bit. Nice thing about whiteout, you guys probably have plenty of room. So 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. Okay, so we're going to sketch in this data. And again, this is a rough sketch, but this is our scatter plot. And so we'd have 7, 1.5, so roughly right here, 5, 0.5, 5, 1, 6, 1, 8, 2.5, and 10, 4. And maybe just to make this a little bit nicer looking, I'm going to put in one more data set. I'm going to put in 10, 3.5. just so it looks a little more linear. Remember, I get to decide to make it linear, so I'm just making this data set up. All right, so these would be my fairly linear, right? It's roughly linear. So I would say there is it's not really strong, it's kind of moderate. I'd say there is a moderate positive linear association between age in years and number of pages read per minute. Okay. So if they asked me to describe the association, that's how I would describe it. If I were to draw like a rough scatter or rough line of best fit, I would try to get it to go through as many of the points as possible, with having as many points above and below the line as equally, I should say, an equal number above and below the line. So maybe something like this. I hope you guys can see that, or even something more like that. Right, but regardless, you're just sketching it in. But what I'd like us to be able to do is understand the difference between this scatter plot and what's called the standardized scatter plot. Okay, the reason is we have to understand where R, or our correlation coefficient, is coming from and how that's calculated. And so to do that, the first thing that we do is we need to standardize each value. So to do that, standardized means our z values. So we're finding zx and zy. I want you to remember the difference between a standardized value on the bell curve, right? Our z value is standardized, and a regular value on the like our x points. All right, so we're going to go ahead and standardize the scatter plot. To do that, to find zx, you take x minus the mean over the standard deviation of x, and y minus the mean over the standard deviation of y. Now we've seen this many times. Z equals x minus the mean over the standard deviation over and over and over again. So it's the same thing here, only we're going to do it once for x and once for y. So what I'm going to do is I'm going to go ahead and go to my scatter plots. I'll remind you of where that is. So to find your scatter plots in your calculator, you go to Stat and then hit Enter, right? And we're going to go ahead and enter our data. Remember, these are corresponding, so you must enter them in the correct order. So 7, 5, 5, 6, 8, 10, 10. Whoops. Make sure you enter them correctly. If you don't, you're going to get the wrong values. And then 1.5, 0.5, 1, 1, 2.5, 4, and 3.5. Okay, so now there's a ton of things you can do with this. So you can view a scatter plot. I'm going to go ahead and do that first. So to view your scatter plot, please make sure you know how to do these things, okay? Second stat plot, you need to make sure that only the first plot is on. And this time we're going to view a scatter plot. So that would be this guy right here, the first one. So I'm going to hit Enter on him. And then it says, what do you want to use for X and Y? Again, I'm going to use list 1. So second list 1 for my X, and list 2 is already there. You can pick what kind of mark you want. I like this little squares, but you can pick whatever mark you want. And for me, I can change my color. And then to view your plot, you hit zoom 9. And there's our scatter plot, and it looks really similar to my scatter plot. Now, if you want to see the line of fit, there's a way to do that as well, and I'll show you that in a few minutes. But what we needed to do this for was because, remember, we need to find x bar and s sub x and y bar and s sub y, so our standard deviation and our mean of each list. So I'm going to get out of here, second quit, and I'm going to go to Stat and Calculate. Now, since I have two variables, I can do a two-variable stat. And I have my X list is list 1, my Y list is list 2, and I'm going to go ahead and calculate. And I'm going to write down all of my data. So it says the X bar is 7.28. I'm going to round it to a 6. And it says S sub x is 2.138. And then it says y, I'll do it in a different color so we can, y bar is 2. Oh, that's awesome. And then the standard deviation is, you have to scroll down, S sub y is 1.354. Okay, so we're going to standardize every single point on this scatter plot. So we're going to have to do this for each of these values. So now I'm going to standardize my x and y values. So when I standardize 7, I'm going to have all these different calculations, right? So z of x1, the first x, and z of x2, I mean y, not x2, my bad, of y1, equals x. So my x value was 7 minus the mean. The mean was 7.286 over the standard deviation of x, which is 2.138, comma, and then it says y, right? So y for 7, right, was 1.5 minus, and I hope you guys can see what I'm pointing at. Yes, you can. Its mean, which is 2, over the standard deviation, which is 1.354. So what I'd like you to do is go ahead and standardize every single value. So I'm going to use my calculator. So 7 minus 7.286 divided by 2.138 is negative, so z sub x, negative 0.13, I'm going to call that a 4. And then I'll do it again for y, 1.5 minus 2 divided by 1.354. Z sub y is negative 0.369. All right, I'm going to pause the video. Actually, I'll do one more with you guys, I guess. Just for those of us who are a little bit slower and need a second example. Right, z sub x2 and z sub y2. So now I'm standardizing these 2 points, right, 5 and 0.5, equals 5 minus the mean, which is 7.286, over the standard deviation of x, which is 2.138, comma, 0.5, so 0.5, minus 2 over 1.354, and that's going to be negative 1.069 negative 1.10, I'll call that an 8. All right, I'm going to pause the video here because we're at about the 13-minute mark. I'm going to fill in the rest of my chart and then I'll come right back on the next video.